Oh, welcome back everybody. Another live stream, part 4. Hopefully the title is correct. On this one I have made the amendment, fingers crossed. That's what you're seeing now. I've done a very small amount of housekeeping. Zoom in here. I've created a component for the UART, the IM6402 device. That wasn't in Proteus originally, so I have created that as a component. These op amps, I suspect they're going to be the driver for the transmit and receive lines. So I've brought those across from the sheet where I dumped everything basically, and we've popped them over on the UART sheet. So we've got a separate sheet for the UART, and I've just included for reference some clips that I've taken from the data sheet just to help us out as we carry on working on this reverse engineering project. This is part 4. Part 1 to 3 is on the replay, so if you head over to the channel you'll be able to see those. If you subscribe as well, you'll be notified the next time we do go live, or if you want to watch it on replay again as we continue this project. The focus today then is going to be surrounding this UART. We did find a few connections going to there from these control lines. So this here where I've labelled, I see one, that's going to pin 23. We should be able to map those in and also see where any other pin connections go. We'll get started and make a bit more progress on this project. I do have a bit of housekeeping to do, so there might be some times where things go quiet, but we will progress. We're probably going to get a good hour or so further work on this project. Let's get started. Okay. A lot of these connections for the UART go straight on to this socket B 18-way header. And looking at that on the screen now, which you'll be able to see going down this end here, get a better thing to point at stuff. We should be able to go down there and make quite a lot of those connections up to that connector fairly easy. This is pin 1. So I think what I'll do, I'll work my way down here, and I'll probably start here because we've got some very easy connections to annotate. So I think we'll be able to do that. So 1, 2, 3, 4, 5, 6, 7, 8. So pin 8 on socket B. Pin 8 on socket B. Pin 8 on socket B. Now, we don't know whether that's an input or an output at the moment until we look at the pin on the UART. Let's see where that heads off to then. And mark that there. Hopefully all the audio's coming through okay. And we have got pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so pin 12. It's probably going to be one of these. Pin 12. Pin 12, RBR1. Yeah, so it is. That's part of the data bus. So that's a receive buffer register. 1, 2, 3, 4, 5, 6, 7, 8. RBR1. That was correctly labelled RBR1. Don't need the underscore bit, get rid of that. Let's just check that on the data sheet. RBR1, yeah, which is pin 12. This was pin 8. RBR1. As we look down here, that was our first one. We know that that was pin 12. Pin 11, 10, 9, 8, 7, 6, 5. Pin 5 goes to 18, 17, 16, 15. So 1, 2, 3, 4, 5, 6, 7, 8. RBR 8. Let's see if we can set the property assignment tool up to deal with this. See if we can get this right. Start from 2. That's it, yeah. I just talked through the property assignment tool. Normally, I could have gone through all of these, right click, edit properties, and type my details in there. But because we're heading through in a sequence, 1, 2, 3, 4, 5, 6, 7, all the way to 8, what I can do is using the property assignment tool, I can set my count starter. So in this case here, I'm going to be looking to label that RBR number 3, RBR3. So I'm going to start my count at 3 and I'm going to increment by 1. So it should go 3, 4, 5, 6, 7. Every time I click on one of these objects on the screen. And to set that up for the string, I'm going to assign the property of net, and I want that to be equal to RBR, and then the hash will be replaced by this counter here. And we're setting the action on assign, and it's gonna be when we click it. Let's go through. There we go. And that just saves a bit of time. Now, another mistake that you can have now is when you next have something else on there and you click on it, the property assignment tool is still active. Okay, so if you call it up and click cancel, that'll then cancel the operation, and you'll not get any unexpected assignments when you click. And again, property assignment tool, we've already filled in number 1. So we want to start the count with 2. And that up there. We're going to drop a bus line on. Okay. They were fairly easy to follow through those. Now I'm going to take a look at, I would suspect, some of these other terminals down here. Probably going to go through to maybe the transmit buffer. Try and see where some of those go. Pins of interest for the transmit side are 26 to 33. Now I will be interested to see whether they actually link up on the underside or whether we've got separate pins for those. Move the keyboard out of the way. And pin 26. This is 21, 22, 23, 24, 25, pin 26. That's interesting because that goes off that way. (26) transmit buffer register 1. Receive buffer register 1 is 12, which is this one here. We've got a direct link there, look. And I'd probably say if we follow that up, 2, 3, 4, 5, 6, 7, 8. Okay, so they all link through. Yeah, okay. I'll click through and assign these. TBR. Transmit buffer register. Ooh. Start at 1. And these lines go off to the RAM chips, which are on the second circuit board. What we'll do as well, look for some easy ones to pick off. We'll have a look to see if any of these control lines are held logic 1 or logic 0. And we've got one to look at here. This is our pin 1. Pin 1, 2, 3. This is ground. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Pin 16. Pin 16 is directly connected to pin 3. So pin 16 is tied to ground. Let's see what that is. Pin 16 SFD. We can connect that in. It's an easy one. Pin 18 of socket B. Pin 18 of socket B is our supply line. And pin 17 is ground, 0 volts. Two easy ones to get done. Back to this, we're looking now for any other lines that are tied. Get you better focus on there. There we go. Nothing on that side. And that one there is going to be tied to 0. 40, 39, 38, 37, 36. Pin 36. Let's see. Pin 36 is this one. That's that. Let's have a look for any more. Looking down this side this time. Any of these pins that are connected through. These two here. These 4, 5. And that one there. These are tied. $39, $38, $37. $39, $38, $37. Let's have a look. 39, 38, 37. They have all together. $40, $39, $38, $37, $36, $35 and $34. All of those. And also further down. Was there any more? No. That was it. Should be. I'm expecting positive. In 39. Connected to pin 1, which is good. This is going to form some of the control inputs that determine the operation of the UART. And we'll have a look through some of the others and transfer across from the rest of the logic and control that we've already determined. I've just got a small amount of housekeeping to do. I shall be back very shortly. me a couple of minutes. I'm just trying to get the statistics up for this stream. Okay. I think we're about there. Just bear with me. Okay. Right, I think we've got all that set up. 1,000 apologies. I'm going to carry on the connection of the UART then. And I've just seen we've got these outputs from the UART here. So we'll connect those up. So I see one pin 27, 28, 29, 30. I see one 28, 29, 30. That's interesting. 28, 29, 30. Did I miss one? $27, $28, $29, $30. $27, $28, $29, $30. So that's TBR 2, 3, 4 and 5. TBR 2, 3, 4 and 5. TBR 2, 3, 4 and 5. Okay. That's interesting because this is then going to form part of our circuit. So it's looking at transmit data there. Let's see what else we can map in. I see 126. I see 126. TBR1. 26 is TBR1. TBR1. So all of this side of the circuitry is to do with the transmit side. Let's see what else we've got. IC121. IC121 MR, so that's a reset line. That's the reset. Okay. IC121. What I'll do for now is I'll map that as an input. Property assignment tool, cancel that. We're going to drop an input on there. IC1_21. That's that connected up. Now we're also going to be looking for another line then, because that's an input and the reset is an input on the UART. So we must have an IC121 somewhere else. IC123, 18. Okay, that could come off the board maybe. I see one. I definitely can't see any others. I see 121. Okay, let's carry on. IC14. It's an easy one to pick off. ORD. That's receive, register, disable if I remember correctly. But again, knowing that helps us determine the functionality of some of this circuitry as we progress. IC123. TBRL. Swap that over. TBRL. Where was that? Over here, yeah. TBRL. TBRL. TBRL, a low level on the transmit buffer register load. Transfers data from the inputs TBR1 into the transmitter. Okay. Yeah, part of the control circuitry for that. See if we've got any more that we can map in. IC121 we said was a reset. We're expecting that to go somewhere else. IC140 is the clock line. TRC, transmit register clock. TRC. Oops. I don't want to delete it. TRC. Register clock. Have we got any more? IC119. IC119DR. That's got to be an output. C1DR. DR. DR. And probably data ready, maybe. DR. A high level on the data received indicates a character has been received and transferred to the receiver buffer register. Okay, so that's going to trigger that. High, low here, takes that out of reset and allows that to cycle through. Okay, fair enough. And IC118, I've already marked that as data received reset. Let's confirm if that's the case. Data received reset. Label that up and connect that in. And we'll relabel this one. DRR. Now I think I should probably update that to MR. MR pin 21 master reset. Yeah, I think I'm going to do that. MR pin 21 MR, and I think there was another one hiding somewhere. No, we were expecting another input somewhere, yeah. Because we've got two inputs and it's got to be driven from somewhere. That should take care of all of our previously labelled IC1R. Now we've got two more here. IC131 and 32. (31) and 32. 31 is TBR6 and TBR7. TBR6 and TBR7. TBR1, 2, 3, 4, 5, 6, 7. Potentially signifying we're only interested in 7 bits. TBR 8 we know. TBR 8. Pin 33. We know that loops round to RBR 8. Let's have a look. Pin 33. $40, $39, $38, $37, $36, $35, $34, $33, nothing there. Nothing there. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 36, 37, 40, yeah, so that's this one. Ah, yeah, I can see a trace disappearing under there, which we know connects up and then goes off this header here. Yeah, that does look like we're only interested in 7 bits of data then. Good progress on functionality of this UART. Now, socket B, did we have any further connections there that we haven't referenced? Socket A we've got. Socket B1. There we go. That was an output. Where's it gone? There. Socket B1 output. So we want an input on here. Socket B1. Let's label that up. Socket B3, we've got one here. That's an out that side, so we need an input. Socket B_3. Let's see what else we've got. Socket B6. Now any of these that are going through, they're going to go through to the memory chips, so that'll be control lines, I would think, to address those memory chips, but we haven't looked at that circuit board yet. Could probably try and chase up some of these pins here, see if we've got any more. There you go, socket B16. Now we'll not find out the functionality of these to give them a better name until we look at that other circuit board. Okay, I think that's all of the socket ones that we can pick off as easy wins. Let's take a look now then. Socket B pin 2. See if we can find out where that goes. There's pin 1, pin 2. Nothing on the component side. It looks like it's a no connection. Yeah, no connection. Pin 4. One, two, three, 4. Nothing on the component side. 1, 2, 3, 4. Nothing on the solder side. Have a look at pin 5. Ah, that goes somewhere. 1, 2, 3, 4, 5. This appears under here, potentially. Along here. Down to here, to that wire there. I think this was one of the tricky ones we were debating previously. It's better. Might not be. See where that goes. So it's in a triangle. So it'll be on the top. As we flip that over. This one here. Which is going to come round to that pin there. I think this is going to be a wild goose chase. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pin 10 of pin 10 of IC9. I don't think this is correct. IC9. IC910. I don't think that's correct. IC9 789 789 2 3 4 5. No. I think that heads off somewhere else. Two. 1, 2, 3, 4, 5 goes across, and that via there by the looks of that. Straight under here to a via there, potentially out of here. 1, 2, 3 between the third and fourth pin. 1, 2, 3, third and fourth, which goes to here. Let's check that out. Oh. Okay, we've got a match there then. That's IC7. In 1, 2, 3, 4. 1, 2, 3, 4. Let's see what that is. I see 7, pin 4 we're looking for. Not that one. I see 7, pin 4. Ah! Master reset. Okay. That's a good find. The master reset is generated from the circuit board. MR. Pin 7 on this connector. That was a really good find. Right, it's 7 on the connector, socket B. 1, 2, 3, 4, 5, 6, 7. There is a connection. Goes through here. One, 2, 3, 4, 5, 6, 7. Gonna come down here. Nothing to give it away here. potentially be those there, but it's obscured by this label. Nothing directly through. Have a look under here. There are connections under there. Six, seven on there. Back a bit. Get a good enough connection on there. Run down here. Okay. I see 9. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, pin 10. I see 9 pin 10. I think we've already got that as a net. Yeah, we have. That's all of our connections for socket B done. Which is fantastic. And again, because that goes off to the memory board, we're not going to be able to get a better naming for that until we see where those signals go on that other circuit board. He's back into here. Socket B1. Right. Should probably try and see if any of these end up going anywhere, shouldn't we? Probably work through these. Let's try IC 1 pin 13. In 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, pin 13. Nothing on the component side. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, pin 13, nothing. And while I'm here, 14, 15, they've got nothing on that side. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. No connections. 15, 16, 17, 18, 19, 20. That case. 13, 14 and 15. We can definitely allocate that they've got no connection. Save our work. Pin 17 we'll take a look at next. (20, 19, 18, 17) do have a connection. Heads off that way. 20, 19, 18, 17, nothing on that side. Suspect it goes through to here. (20, 19, 18, 17) through to this one, potentially all the way through to here between pin 1 and 2. Could be this here. Don't think it is that. No signal there. Take a look off camera with a torch. Okay. With a torch directly under the board, it looks like it goes to pin 40. I can get both of those on the camera at the same time. 20, 19, 17. Okay. TRC also goes to RRC. Which would make sense. That's our clock line for the transmitter and receiver. Pin 20. Have a look at that next. We have a connection. Looks of that. 20 here. So down here, along here. Let's go up to this resistor. On. Here. potentially to this transistor. We've got this resistor tied to ground. R11. R11. Continuity that. Yeah. Okay. And R11. Pin. 1, 2, 3, 4, 5, 6, 7. R11. Which is 1, 0. And 10k. Did we pop that on our circuit already? R11. It doesn't look like we did. R11. R11, 10k already. One side of that was connected to ground. Drop that on. Save that, and we're off then to ZTX 107. Not in our parts bin already. ZTX 107. ZTX. Okay. Drop this in. ZTC, ZTX 107. E-line, yeah, that's fine. Now, so it's going to pin 1. Pin 1 is the collector. Pin 3. Resistor by the looks of that. potentially there. See if that's the case. No, I don't think so. Nothing on the underside. That's got to be the base down to this. Ah, here. Okay. So I think that's some kind of power supply line. That's big resistor there. This here. Yeah, just compresses there. That resistor. Like it's a connection line. Checking the socket A. Socket A for that. Nice. Okay. Put that down to be checked. Where does that base go then? The base. This goes round to here. This is a diode. Connection there. 79C. Ooh. Lose the last markings, which is the important bit. Let's have a look. Side of that Zena. Here. It looks like it's 2, 3, 4, 5, 6, 7. Looks like it's a fault line. Drop that one in yet. We haven't. BZ. BZX. 79. C. Let's just drop that in as a generic one for now. To 0 volts. Now, according to that then, there should be something else happening. Also goes to this resistor directly up there, which goes to this op amp. Okay. Brown, black, orange, so 10k. Also goes off. From that Zena, got a 10k. Also got a 120 120k. 10k and 120k, and that goes to pin 1. Op amp. In 1. $120k. 1, 2, 4 zeros. $10K. R13. R13 is the 120K. And R12 is the 10K. We're interested now where the other side of that resistor, R13, heads off to. $14. Trace going up there. I think this will be fed back to the input. Trace there, so some kind of, oh, I suspect. R14, 4700, 4K7. R14, 4K7. Potentially pin 2 or pin 3. There, but I might not be through this conformal coating. Pin 3. Goes round to pin 3. That's our feedback. see where pin 2 goes. Disappears under here. Potentially there. Was there? Here. Ah, no, actually. See, it's not that via that directly under there. Looks like it's going straight through here to R15. R15 10001K. Pin 2 then. R15. 1K. One, two, three, four, 7. Pull down resistor. There's also another this component directly above that. C13. Yeah. C13 also pull down. Got to be another connection somewhere then. Is there or not? Maybe there. Maybe there isn't. That's just going to be held down. Okay. No. So our other input is from R14. Okay, that one. I wonder if that goes to socket A, which would be data in. Pins they are. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 and 12. I'm going to label that RxD. And we'll label that up there, RxD. And the only unknown at this point is where that heads off to. We could continuity that out to 0 volts. Let's see. No. Something else going on with it. Though no, let that one go for now. I'll let that one go. Well, we've made quite good progress there. I'm expecting this side here to be part of the transmitter circuitry. Expect it to be RC. Yeah, I think that's going to be part of the transmit data. Yeah, I'm happy with that progress. Well, that was part 4. Currently on part 4. If you've enjoyed that, do give it a thumbs up and subscribe to make sure you don't miss part 5, which will be coming next. I'm going to sign off for today. Thank you very much, everybody, for watching. Hope you have a good afternoon. It's Sunday afternoon here. Late afternoon here in the UK. Thanks very much. And I'll see you in part 5.